All right, welcome everyone. Hello. So this talk is going to be about exploring application portability across public cloud providers using K8s. By the numbers, it looks like you guys are here for the early happy hour. So sorry, there isn't a keg. So hopefully you're really here for our talk.
All right, hello, my name is Ivan Font. I'm a software engineer for Red Hat. I'm a Kubernetes member and a SIG multi-cluster core contributor, and I'm working on various multi-cluster projects. One interesting thing about me is that I will be a father sometime early next year.
All right, my name is Erin Boyd. I'm a contributor to Kubernetes. I work in the office of the CTO for Red Hat. And an interesting thing about me, this was me 40 minutes ago in the speaker's lounge because we just got our demo working. So yes, very excited. So pray that it still works now that we've switched over to a different Wi-Fi. So let's get started.
All right, so show of hands, how many of you have heard of Federation version 2 in Kubernetes? Okay, a few of you out there. So I won't go into too much detail here, but if you're interested in more details, we do have a SIG multi-cluster deep dive session on Thursday morning at 10:50 that I encourage you all to go to. So what is Federation? Well, it's the ability to manage n non-homogeneous Kubernetes clusters. These could be clusters in public cloud, private cloud, basically any Kubernetes cluster that you have the API server access information to. And so it basically allows you to synchronize your resources across all of these clusters. It also enables high availability, and it does that by basically allowing you to distribute your resources onto different clusters, and so you don't have a single point of failure in any single cluster. It also enables freedom of choice, and basically it allows you to freely be able to move your application onto any cluster that you have, and it really reduces the burden to doing that. So what do you get with the Federation version 2 that we have today? Well, it's a CRD-based Federation API, so you get a native Kubernetes experience. You can talk directly to the Kubernetes API server in the host cluster that's hosting the Federation control plane, and you can configure the control plane directly through that. You also have the ability to federate any resource type. And so this could be a resource type within the core Kubernetes, so like a deployment or a service, or it could be any custom resource definition that you define, as well as any API that you're aggregating via an aggregated API server. You also get the ability to specify overrides, so you can have field-level overrides by specifying some sort of difference from one cluster to another. So for example, if you have like deployments and you want to specify replicas, a difference in replicas from one cluster to another, you can do that via overrides, and we'll see a little bit of that. You also get the ability to specify placement decisions. So you can provide these placement directives that dictate where you want your resources placed in your set of clusters in your federation. And we support basically a list of clusters or a label-based selector on your clusters if you categorize them and label your clusters that way. We also have dynamic scheduling. So you can basically, for replicas or deployments, specify a certain number of max replicas, and you can provide preferences and rules to distribute those set of replicas amongst your federation in any particular way that you want. And then lastly, cross-cluster service discovery. Basically gives you the ability to discover your services across clusters. It's a DNS-based mechanism, and it does that via federated services and federated ingress, along with a project called external DNS that allows you to program various different DNS providers. So one of the things Federation enables is application portability. And so we define that as these use cases here, which is basically having the ability to move your application and perhaps its data onto a different cluster. This is Kubernetes clusters, of course. Also the ability to burst your application onto multiple clusters, depending on like workload demand, as well as possibly removing a cluster or failing over by removing it from the federation and having like zero downtime for your application. And so now I'll hand it over to Erin to talk about the data.
Okay, so storage is arguably one of the most sticky parts of migrating applications across clusters. So we've come up with what we think are kind of the general patterns around migrating data. So the first one is stretch. This is kind of a word we came up with at Red Hat. That's just how we envision it in our head. But it's the ability to take one single volume and stretch it across the federation, meaning I have a single volume that's accessible from AWS, GCE, and Azure all at the same time. We have also a pattern of geosensitive or cloud-specific. So if you're running a high-performance application, you may want to use a federation pattern to keep that type of persistent volume that's native to that cloud or the default storage class as what you're going to store your data within. And we'll actually show you that within our demo. The next one is containerized storage. So for software-defined storage, there are a couple different options in the Kubernetes ecosystem where we can actually have containerized storage within Kubernetes. And with that, we can actually federate the storage, although we've only got it working in a homogeneous set of AWS clusters. You can actually deploy a federation application, have it create the storage on the clusters that you're going to at the same time. And this affords you the ability to have a single control plane with both your application and your data, which is really slick. And then the last one, last but not least, there's always brownfield. Not everything is green. We talk about a control plane where you leave the data in place. Now, this isn't an ideal situation, but I think in Kubernetes, we try really hard within the storage SIG not to dictate how you should do something. We should just be exposing the ways that you can. And it might be that in your enterprise, you want to leave the data in place. You have a private cloud, it's sensitive data, and there's no way you want to migrate that to the cloud, but you want to expose the application itself, storing the data locally. Federation, the last pattern allows you to do this. You can leave your database in place on your private cloud, still run your application in the public cloud, and write the data back. So with that, let's see it in real life.
All right, so let's take a look here. And let's show you the current state of things here. So what we have is a set of Kubernetes clusters. We have a cluster running on AWS, GCP, and Azure. And we've deployed the federation control plane onto the GCP cluster specifically. And we've deployed containerized MongoDB onto each of the clusters with the federation control plane. And we deployed containerized MongoDB, and we created a replica set. So we're replicating data within Mongo. We then took a reference application like Pacman, and we containerized it. It's based on Node.js, and we deployed that through the federation control plane as well. And we have that running right now on AWS and GCP. So I'm going to transition to the terminal here. And on the right, you will see the list of, let me increase that a little bit. All right, so on the right, you can see that we have a watch running on each of the, let me expand that a little bit. We have a watch running so that you can see the pods in each of the clusters. And on the top, you can see we have the GCP cluster, and it's running 5 instances of Pacman there. And we have the AWS cluster here, and it's running 3 instances of Pacman. And we'll talk a little bit about the differences there. But let me show you the configs that were involved in deploying this. So here we have a federated deployment, which is a resource type defined by the Federation-v2 API. And it embeds a Kubernetes deployment spec within it. And it's just some basic standard deployment stuff within that spec. And so here, the interesting part is that we're listing we want 5 replicas. Similarly, we have a federated deployment override. And if you were wondering why the GKE cluster here shows 5 pods and AWS only shows 3, it's because we have this federated deployment override API that we basically can list a set of overrides. So on the AWS cluster here, we're wanting to override the spec.replicas, and we specify the value of 3. So we only have 3 pods running in AWS, and the default is 5 for anything else. And then we have the federated deployment placement resource here, and it basically provides the list of clusters where we want to federate this resource. And here you can see that we've listed our Google Cloud cluster and the AWS cluster. And this could similarly be a label selector if you had labels on your clusters. So now that you've seen that, let's go ahead and play some Pac-Man.
Yeah, who wants to play Pac-Man? You guys want to play with us? Yeah.
All right. So here you can see that on the top we have a...
Hold on real quick. Can you guys see the URL to join?
Yeah, it should be at the top there.
If you have an iPhone, it's not going to work.
So feel free to play along on your laptops or Android devices. But I'll show you up live here in case you don't have a compatible device. So the cloud here, you can see that we're running on Google's cloud and some other pertinent information like the zone and the host. So similarly here on the right, you can see kind of a live stats being updated as folks are playing. And I'll go ahead and play around here.
You're not very good at it.
No, just trying to collect some score here. And let's save that as Ivan1. And we can view the high score here. And we see that Ivan1 was persisted running on Google's cloud with a high score of 370. So let's go ahead and refresh. And you can see now we're on the AWS cloud here. We have a load balancer that's just performing round robin across the different clusters. And you can basically play on both cloud providers. So let's play another round here.
Now you're bringing your game. You know, there's no
Yeah.
prizes.
Trying to be my A game here. All right, let's save that as Ivan2. View the high score. Looks like we've already got some people playing here. So there's Ivan2 on
nice.
AWS, and with the high score of 790. So now that you've seen that, let's go ahead and transition back to the slides here. So since there's a lot of people playing, let's say that we need to scale up our resources a little bit, and we need to add another cluster to the set of clusters that are running this Pac-Man instance. Well, with Federation Control Plane, we can do that really easily just by editing the federated deployment placement. And this is that resource that I was describing earlier. And we're just editing the live config here. And we'll go ahead and add the Azure cluster that's running in the central part of the US. So save that. And on the right, you'll see the list of Pac-Man instances coming up. And we have 5 pods running there. And the load balancer will detect the cluster coming online. And so if we go back to our game here, we can hit refresh. And there's Azure right here at the top. And let's go ahead and play around. All right, that's probably good. All right, we'll save that as Ivan3. View the high scores here. And Ivan3 is clearly off the page because I'm no longer that great. And here's Ivan3 running on Azure's cloud with a high score of 720. So just to show you the other cloud providers, let's just refresh, and here's AWS. Let's look at the high score. We can see that Ivan 3 is there. And let's refresh again. Let's get GCP. And there's GCP. And we can look at the high scores there, and we can see that the same scores persisted. All right, so we're running on all three cloud providers pretty easily. And so let's go ahead and decide, for some reason, whatever reason you have, we want to migrate away from AWS and just be running on Azure and GCP. So similarly, as you saw earlier, let's go ahead and just remove AWS. And you can see on the right there, Pacman resources are gone from AWS. The load balancer picks up that change. And we can come in here, and if we hit refresh, all right, we have GCP. Let's look at the high scores again. You see all the scores are in there. Refresh one more time. And people are playing, apparently. And there's Azure. And we can see the high score. And you can refresh this as many times as you want, and you will not hit AWS.
Pretty slick. So thank you, Ivan. That was awesome. So what you didn't really see was storage, which you shouldn't see, right? Storage should just be easy. It should just work. So when we originally dreamed up this demo, we thought it would be really cool if I used one storage provider for everything that I wanted to do in my cluster. So we wanted to put our stretch volume on Mongo. We wanted to use our stretch volume for our logs. Well, that didn't quite work out the way we wanted it to work. Similar to this. I don't know if you guys have seen this video on LinkedIn. It's like we built this playground when we tried that pattern. Come on, load. Notice no one is using the slide. So having the stretch volume on top of an application that already provides replication is similar to this. It's completely unnecessary. And Wi-Fi's not great, so let's move on. Maybe. So I kind of call this my tinfoil hat pattern. So if you're super paranoid that you're going to lose the data and it's that important and you feel like you need to double replicate something, then sure, it does work. We got it working. But probably not the best pattern. It's expensive and unnecessary. Double replication doesn't equal double prices. So what could we use our stretch volume with? Where does that feel like it fits into this whole federation pattern? And what did we end up doing? So what we ended up doing was actually pretty clever. So we took on each cloud provider using its default storage class, so AWS, we used an EBS volume, and GCE, we used a PD. We were able to federate Mongo and just say, create me a PVC combination, bind it, and use that storage type that you natively use. And I don't have to worry about it. It just works. As Ivan showed us, the high scores are still propagated and replicated completely across because that's what Mongo does best. And we're just going to let Mongo do its thing. But then we wanted to highlight what federation affords to something like a stretch volume. So what we did is we ended up stretching our logs across that. So we were able to take the logs that Mongo produces from each of the instances and write it to a single volume. So everyone's kind of yawning who cares about logs. Probably a lot of DevOps people care about logs. And if you don't care about logs, maybe you care about an aggregate of the data to be written to this stretch volume. So we kind of refer to this always available everywhere all the time. And if any of you were able to attend the CNS Day yesterday, there were a lot of customers there that were interested in exactly being able to have this ability within Federation, that you want to have a little subset of cache data possibly available through all the clusters everywhere. And even if a federated instance goes down, it's still persisted and it's not lost. So let's show the logs real quick just to prove it to you, make sure we're not lying.
So I'm going to SSH to the instance here running on GCE, and I'm going to CD into the mount point that's hosting these logs, and you can see that we have the logs running for each of the Gluster instances in each of the cloud providers. So you can see AKS here for Azure, GKE here for GCP, and EC2 here for AWS.
And even though we killed the AWS instance, again, it's persisted, it's still there, it's not updating like the others, but the data's still there and available. So if you do have a critical application that you're trying to debug that dies in one of your federated clusters, you then still have accessibility to that log from anywhere to be able to fix your problem. So that is our demo, and it actually worked, so yay. Go ahead.
In the scenario where you talk about spiking for demand, and why would you want to do that across multiple clouds instead of just in the same cloud? And also, where did you put the load balancer you said was the demo where there were all of those three applications?
So the question was, in the scenario where we needed to scale up the Federation clouds, why did we not expand it within the current cloud? Why did we expand it to a different cloud? And then what was the load balancer we used?
So we used an HA proxy load balancer, and it's hosted in, I can show you HA proxy load balancer. It's a deployment running on GCP's cloud, and in it has the configuration that with a health check for the Pacman load balancers running within the clusters themselves and load balancing across all of the clusters. So it's like a two-tier load balancer setup.
So the reason why we scaled to a different cloud is just to show the flexibility of the Federation control plane. So there's a lot of like, what's the difference between multi-cloud and multi-cluster, right? So we're trying to highlight that. It's multiple clusters on multiple clouds. So it affords you the flexibility to be able to have that choice that something went wrong on AWS and I want to scale it up on, GKE. So no other reason than just to show the flexibility, I guess. Does that answer your question?
Well, you mentioned that one of the benefits of this is that it can handle the spike or I forget the term you used, but and that's like more of an HA scenario that you just talked about. Well, what about in a spike scenario, if I'm already paying one cloud and I've got my application deployed there, is there any benefit to are there any drivers that would cause the customers to want to move to another cloud just when they need only additional capacity?
I think that would have to be on a customer-by-customer basis. I mean, I think the whole point is just that you have the choice. It depends on the money. Let's say you have a bunch of free credits on Azure and you want to use them. Why not, right? So. Okay. Go ahead.
Well, we're using a Cluster Registry and a resource called Federated Clusters, which basically provides RBAC credentials to the control plane itself to be able to create and modify the resources necessary in each cluster. If you wanted to provide more fine-grained control, you could federate your RBAC resources however you see fit. So you would define them and distribute them through the Federation control plane however you want to define your resources. So you can federate like service accounts, cluster roles, cluster role bindings, and that type of stuff as well.
Way in the back.
Did I understand that you have different Mongo pods in each public cloud talking to each other, like local storage?
Yeah, and I've been bad about repeating it. So you were asking, did you understand that we were running different Mongo pods in each one of the cloud providers, correct? Yes. Yes.
It's actually using a service load balancer that's accessible across the public internet. Not necessarily something you want to do for security reasons. We are looking into other networking facets of this problem where perhaps we can tunnel traffic between clusters, but there's definitely a lot of networking use cases that we need to consider as we continue to evolve this project.
So to contrast that with the stretch volume, would that be Kubernetes layer replicated storage across clouds, or is that working?
Would it be a Kubernetes? I guess I don't know what you mean by that question. Yep. So the stretch volume is still using Kubernetes primitives. It's still tied together with that pod through a PVC claim. So when we set up the log, we just told it to write to this persistent volume claim. So above everything else, it's still using, Kubernetes API primitives to be able to define these resources. So they're one and the same. You're welcome. Go ahead.
How does it integrate with tools like COPS, migrating, and are you using a network overlay across the cluster?
So you said, how's it working with COPS and K8s? Yep.
Cluster Federated-v2, like upgrade applications version, deploy all of the K8s operations or KubeADM similar, and do you use a network overlay?
Okay, so the question was basically how are you administering it across the cluster, and are you using a network overlay? So
we're not using a network overlay. I think the question is how do you handle upgrades through the Federation control plane? That's a very challenging use case that we need to consider as we go forward. We're still in the alpha stage, so we do have a pretty strict requirement that the clusters need to be at least at the version of the host cluster, which is 1.11 right now. But as we continue to progress and evolve the API and eventually hit beta, we need to start considering the aspects of upgrades. There is cross-cluster communication because the Kube API server in each of the clusters is available on the public internet.
Yep.
As long as your credentials are set up appropriately, you can access and configure the cluster, and the control plane, the Federation control plane itself, can access the Kube API server in each of those clusters. Great question.
Yep. Go ahead.
How does Federation play with something like Istio? Can it know that you have a future application or something and know that one is down in one and route to the other cluster? Is there a relationship there, or are they not connected yet?
So the question is, how does Federation relate with things like Istio? We actually have interest in the community on federating Istio itself. So there was actually a presentation, I believe, earlier today for the SIG multi-cluster intro, where Istio itself was being federated using the Federation control plane. So you can think of the Federation as this very low-level set of primitives that can be built on top of, and you can federate other higher-level applications like Istio in this example. Question over here? The question is, where was the Federation control plane deployed in this case? And it was deployed on GCP's cluster. That could have easily been deployed on AWS or Azure as well.
In the front. Yep.
Good question. Are there any latency considerations with the deployments in each of the clusters, where the Federation control plane is kind of needing to access these clusters that are spanned across different regions? Yes, except it's a declarative API, so all it's doing is really just making sure that that resource matches what you're requesting. So there isn't necessarily like a continuous sort of latency aspect that needs to be considered. Of course, these clusters are in the US region, so they're a lot closer, but we haven't really seen any latency requirements like that around distributing the resources themselves.
But it is one of the pitfalls, right, of federation, is the expectation that you're going to have a certain network, performance baseline that, especially with storage, you have to consider in distributed storage. So, you're going to have probably near real time and eventual consistency, but you're not going to have that right out of the gate, depending on your network. So, that is a consideration, and that's something to consider if you decide to go through federation, is what kind of network bandwidth am I going to have, right? And then the ability to switch, but again, the design allows you to switch. Like, let's say that zone is really slow, or you have your cluster federated somewhere, and you can bring it closer to where it is. You can, switch zones as you have to if there's network latency problems. Because I have seen that. I have seen where there's, bursting and latency depending on what cloud you're in and what geography.
Let me add to that also. So one of the things to consider, too, is the HA aspects of the federation control plane itself. And there are etcd latency restrictions that really inhibit the ability to kind of provide an HA federation control plane itself. This mechanism uses a push reconciler, where you're running the controller inside of the host cluster, and it's actually pushing resources to multiple clusters. To kind of get around some of that, there's potential for introducing like a pull reconciler mechanism, where you have controllers running in each of the clusters themselves to kind of provide some of that HA aspect, and then they're pulling from kind of a common repository or something, like using Git, for example. Question over here?
We are experimenting with Ceph, yes, for sure, and Cluster and a lot of the different storage providers. So
one big Ceph fabric across multiple clouds.
Have not got that working. So far, just Cluster. Yep. So I think we're at time. I'm getting to stop. But thank you, everyone. If you have other questions, please feel free to reach out to us.
Yeah, we're up here.
We're up here.
You can
email us, hit us up on Twitter. Thanks again.